Hello everyone, welcome to my class. Today, in the world of statistics, we will study an amazing topic that is a one way ANOVA test. In order to learn a one way ANOVA test, we will study these four topics today. Although this topic looks different from each other and doesn't look like they are in sequence. But this is the way we will learn about them so that understanding them can be easy. We will start with the important terms and assumptions of one way ANOVA test, and we will end our lesson with what is ANOVA statistical test. So we have four topics: important terms and assumption of one way ANOVA test, why one way ANOVA statistical test is used, what are the steps do one way ANOVA statistical test we have, and what is a ANOVA statistical test? So let's start with our first topic. What are the important terms and assumptions of one way ANOVA test? Before we start learning one way ANOVA test, we must know some important terms. As you know, whenever we start learning about research, we know there are two type of variables we usually study. It can be a quantitative variable or it can be a qualitative variable. And we also know that in qualitative variables, we can see this. This is called a categorical variable. A categorical variable have categories. So let's see with an example. As you can see, a medicine is a variable we want to study. If you are studying three medicines, there will be three categories: A, B, and C. If you are studying about fertilizers, there will be three fertilizers: A, B, and C. If you are studying about a gender, there will be two genders, male and female. If you are studying about happiness, you can see three categories: little, high, and very high. We see that we are studying something, right? We are studying a variable, but that variable have categories. Now, a categorical variable, as we have just seen in our example, that we have four type of categorical variable. Now, look at these bright color things. We have medicine which is have categories A, B, and C. We have fertilizers that have category A, B, and C. We have gender which have categories male and female. Do you know that all these three variables that have categories, they are nominal variables? We know that medicine, fertilizer, and gender is a part of data. And the first level to know about a data is to know by its name. They are just a name, and names have categories. Medicine is a name and it has three names: A, B, and C. Fertilizers have is a name and it has three names: A, B, and C. Gender have two names: male and female. So they are just a nominal variable, because a nominal variable data can only be have one quality, that it can be understood by its name. It means they are categorical, but they are can only be studied by their name. But let's look at the happiness categorical variable. Happiness have three names, three categories. It has name little, high, and very high. It means it has three categories. But little is different, high is different, and very high is different, they all show one more quality of itself is that they are in ranks. They are in order. When a data has names and it is also in order, that variable is known as an ordinal variable. Now let's talk about the independent variable. As we know, if we change anything in the medicine A, B, and C, it can have an effect on a disease. It can affect on a problem of the body. If we talk about fertilizers, they can have effect on the growth of a plant. But if we talk about gender and happiness, they can also have an effect on something. But the most crucial type of variables which can have effect on something, we are taking them as medicine and fertilizer today. When a variable has an effect on another variable, it means that one variable which will change and it can impact the another variable. The first variable will be called as a independent variable. And why we call them it a factor? We call that variable a factor because it is the reason that other variable will change. It means other variable cannot change the first variable. The first variable can change the second variable. So who is the factor? The factor or the responsible variable is medicine or fertilizer. Now Ankit sir, what it can change? Yes, a independent variable can change a dependent variable, and a medicine can change reduction in fever. It means if you are studying the effect of medicine on reduction of fever, we are studying about two variables, that is independent variable and dependent variable. It means when we form a categorical variable, we can see relationship of two variables, independent variable and a relationship of the independent variable with the dependent variable. Now let's look at this. In medicine A, B, and C, if we change the composition of the medicine, it can have effect on the reduction in fever of a person. And if we change a fertilizer A from B to C, it can have effect on the growth of a plant in centimeter. Now why there was a need to show in Celsius and in centimeter is because in order to do a one-way ANOVA test, the, the dependent variable must be in ratio or interval scale. It means it should be on a higher scale. As we know, there are four scales of measurement in research in on our data. Data can be measured on four scales: nominal, ordinal, ratio, and interval. And ratio or interval scales are also called the metric scale because they are higher scales. Because fever can be measured in Celsius, it is a higher scale of measuring a data. Growth of a plant can be measured in centimeters, it is a higher scale. So, in order to study a one-way ANOVA test, first thing we must understand is our understanding of categorical variables. Categorical variables create two variables in a data. Independent variable, which are known as factors, and it will also create a dependent variable. It means you will see a data in which one variable will affect the another variable. For example, medicine will have effect on the fever. Fertilizers have an effect on growth of plant. It means there are very high chances that our independent variable will be on nominal scale and our dependent variable will either be in ratio or an interval scale that are also known as metric scales, but our dependent variable will never be in a nominal scale. Let's create a data table. This data table is a table of a categorical variable. Now, how do we know that it is a categorical variable? Because it has three categories: fertilizer A, fertilizer B, and fertilizer C. Fertilizer A has an effect on the growth of a plant in centimeter. Plant A is growing 3 centimeter, plant B is growing 4 centimeter, plant C is going 5 centimeters. So we can see that in this data we have two variables: independent variable fertilizer A, and it has effect on the growth of plant. The growth of plant is a dependent variable because fertilizer has effect on the growth of plant. It means growth of plant in our data is dependent on a fertilizer. So the reason we did all of these topics before we start knowing about one-way ANOVA test is to know that which kind of data we have to face in order to do a one-way ANOVA test. Now we know we cannot do a test on a data if we do not assume something about that data. A data must follow some conditions, otherwise we cannot apply our test. It is the first and foremost condition of one-way ANOVA test is that all the plants that you are choosing for fertilizer A, for fertilizer B, and for fertilizer C, you will select all the plants randomly. You cannot choose a plant by your choice. One more assumption we have, that while selecting plants for fertilizer A, the plants will be different. While selecting fertilizer B plants, those plants will be different, and the plants of fertilizer C will be different. It means all the samples of all the plants will be different from each other. One more thing we have to assume. For example, in fertilizer A, we have plants A, B, C, D, and E. This data 34531 will be normally distributed. It means average, most of the data will lie near to the average, and some plants will go far away from the average, and some plants will be very low from the average. It will behave just like a normal data, and it is a very important condition for one-way ANOVA test. One more condition of one-way ANOVA test is that the variance of all the groups fertilizer A, fertilizer B, and fertilizer C will be almost equal. If variance of all the groups is not approximately equal, one-way ANOVA test will not be a good test. So in general, we need these four big assumptions. Plus one more thing we have studied is that data should be categorical variable. Because, because now we have a little idea that what kind of data we have to face when we do a one-way ANOVA test. So let's study why one-way ANOVA statistical test is actually used. Now, for example, I am a researcher and I know if I want to say something about data, I have to conduct test on it. In order to say something with surety and with proof, I have to do test on it. But if I am picking one-way ANOVA statistical test, it can only be possible if I want to know that population mean of more than two groups is different or not. As we know in statistics, we take samples and we predict about the population. And the only way we can be assured about our decision The only way we can be sure on our decision is we must take samples and do tests on them. If I take some samples and I wanted to prove that population mean of more than two groups is different or not, this is the reason why I will use a one-way ANOVA statistical test. So in our case, how many groups we have seen? We have seen three groups. It is very much important the group should be more than two. Otherwise, there is no need to do one-way ANOVA test. We can simply shift our decision to take a test which is known as the t-test. The question will be same, but our groups will be more than two. In case of a one-way ANOVA statistical test, and our groups will be only two in case of a t-test. So what we learn is that the reason we use one-way ANOVA statistical test is because we wanted to know is the population mean of more than two group is different or not. Can we say with assurance, can we say with our surety that what our samples are showing, can we say the same about the population? So this is the reason we use a one-way ANOVA statistical test. Now, our next question we wanted to know is that what are the steps we should do to conduct a one-way ANOVA statistical test? Yes, as per my knowledge, one of the most lengthiest tests is one-way ANOVA statistical test. So here are the basic steps we have to perform. We will learn about these steps one by one, but let's read about them. We have to choose a significance level. In our case, we will choose a 5% significance level. We will make two hypotheses. We will apply the formula of one-way ANOVA and we will find out F statistical test value. And once we find out the F statistical test value, we'll find out the critical value with the help of degree of freedom, and then we will compare the critical value to F test statistical value, and then we will make our final decision. So there's no need to get confused because we will understand each step one by one. And remember, every test have a formula, right? Although one-way ANOVA has a name one-way ANOVA, but its test is famously known as F test. And F stands for a formula which is called between the group variance upon within the group variance. It means our formula to solve a one-way ANOVA statistical test will be between the group variance upon within the group variance. So let's study about our first find. We have to choose a significance level. As you know, whenever we do a test, first of all, we have to show some confidence on our samples. How much sure I am that my sample will tell me or predict very much right about the population. How much true it is that my samples are the right representative of my population. Of course, there will be so many samples which cannot be rightly suited for your population. It means there will be some sample which cannot represent your population very well. But most of the samples will represent your population very well. When some samples cannot represent your population very well, you have little fear that some sample will not represent my population. That fear is called a significance level, and we have selected it to be on 5%. It means there's 5% chances my sample will not be the right representatives of my population. Remember, we cannot do any test if we don't decide our confidence in the beginning, if we don't decide our fear level in the beginning. So our first responsibility is to choose a significance level for our test. In our case, we have selected 5%. Now, our second step is that we will choose, we have to make two hypotheses. Very easy question. We know there are two type of hypothesis. We know hypothesis is the assumption about the population we have to make. It is the only way to do a test. We have to assume something. So there are two hypotheses. One we have null hypothesis and one we have is alternative hypothesis. Our null hypothesis is one hypothesis which we wanted to prove wrong. What we want to prove wrong is that population mean of all the three fertilizer will not be equal. And what we wanted to prove, what we wanted to get right is that population mean of three fertilizer is not equal. So what we wanted to prove wrong is null hypothesis, and what we wanted to prove and what we really wanted to win is the alternative hypothesis. The only reason we will study point C is once we make a hypothesis. We cannot learn point C without making understanding of point A and point B. Now we will apply the formula of one-way ANOVA and we will find out a F-test statistical value. Now when we do a test on our samples, it is called statistics. But the answers our samples give is always a result of a test. In our case, if we are doing our test on samples of one-way ANOVA data, the result will be a F-test answer. And there is no doubt that F-test is equal to between the group variance upon within the group variance. It is the formula of this test. Now solving a test is a cumbersome exercise. So we have divided into some parts. So let's look at our data and try to solve it with the help of example. The first thing we will do is that we will find out the mean of all data. So fertilizer A have 5 plants, fertilizer B have 5 plants, and fertilizer C have 5 plants. In total we have 15 plants. One thing you have to keep in mind that the samples in one category cannot be less than 5. The sample must be more, the overall sample must be more, they must be large. The more large the samples are, the higher the chances one-way ANOVA test will give you a better results. In our case, we have taken a little less samples to make the question look easy, but generally you will see a large sample in case of one-way ANOVA test. So let's find out the first step to solve a one-way ANOVA test or a F test is that we have to find out mean of all data. So here G stands for mean of all data, X stands for plant 1, plant 2, plant 3, plant 5, their values. And it is the summation of all the fertilizer growth, plant growths. Divided by number of plants we have 15 plants. So we add all the fertilizers, plant growths and divide it by the number of plants we have. How many plants we have? We have 15 plants. Sum of all the data is 44 centimeters and we divide it by 15, which are the number of plants, and our mean of all data will be 1.76. This is the first step we will do. The second step we will do is that we will find the mean of each group. It means mean of fertilizer A will be different, mean of fertilizer B will be different, mean of fertilizer C will be different. So MI stands for mean of first fertilizer. First fertilizer has a mean of 16 divided by 5, that is 3.2. Fertilizer A has X values 3 plus 4 plus 5 plus 3 plus 1, and fertilizer A has only 5 plants. So the mean of the first fertilizer will be 3.2. It will be the same exercise we will do on all the 3 fertilizers. So what we did in our previous exercise is we find the mean of all data, and in the next exercise we find the mean of each group. The third thing is a little complicated. It is called the sum of square between the groups. As we can see, sum of square is SS and BTW means between the groups. Here NI stands for number of plants in a group, that are 5. MI stands for the mean of the fertilizer 1, mean of fertilizer 2 and mean of fertilizer 3. We will minus the mean of each fertilizer from the overall mean of the data, and we will square them one by one. So number of plants are 5 into brackets 3.2 is the mean of the first group minus the mean of all group, that is 1.76, and we will square that difference. We will plus it with the second group, same exercise. 2.6 is the mean of the fertilizer B minus 1.6, the mean of all the data. So once you finish this exercise, you will see that the sum of square between the groups is 21.584. Now we will do the fourth exercise, that is sum of square within the group. Now within the groups means the mean of fertilizer A only will be minus from its own values. Sum of square within the group is called SSWI. WI stands for within the group and SS stands for sum of square. As we can see, XMI. X stands for the value of the fertilizer A, 34531. X can also be value of fertilizer B, 23413. And let's take example. Fertilizer A has the first value 3. We will minus 3 with its own group mean value, that is 3.2, and we will square it, and we will do it with the same within the same group with all the values like 4, like 5, like 3, like 1. For fertilizer B we will do the same thing, 2, 3, 4, 1, 3, and we will keep adding all these within the group differences, and we will square them. And not only we will square them, we will sum them. In the end we will get an answer, that is 24. Now step 3 and 4 are very crucial. The fifth step we will do is we'll find out the mean square between the group. As you know that we find out the mean square between group, it means we have to take out the mean of square between groups. So on the numerator we will put sum of square between the groups, which was 21.584, and in order to find its mean we have to divide it with degree of freedom. But the degree of freedom will be of between the group first. The question come in our mind is, what is degree of freedom? In order to find out a degree of freedom, as we know, we can choose 2 fertilizers with our own choice randomly, but the last fertilizer will be our only option left. This process is called degree of freedom in choosing a random sample. We have selected 3 fertilizers, so our degree of freedom in selecting a fertilizer will always be 3 minus 1. So our degree of freedom within the group will be 3 minus 1, that is 2. So the mean of the square between the groups will be 10.792. It is a very crucial step, that is the fifth step. Now in the sixth step, you will find the mean of square within the group. The square within the group was the numerator, which is QSIN, which we know from our previous exercise, that was 24. But in order to find its mean, we have to divide it with the degree of freedom of within the group. As we know, we have 15 samples of plants, and we have total three categories. So 15 minus 3 is 12. So our degree of freedom is within the group will be 12. So the mean of the square within the group will be 2. So now we have our seventh step, which is the F-test formula. We remember from our beginning of the lesson that the F-test formula or F-test statistical value is sum of square between the groups, or we can say between the group variance divided by within the group variance. So in our exercise 5 and 6, we find out the mean of sum of square between the groups and the mean of sum of square within the group. So the between the group variance will be 10.792 and within the group variance will be 2, and our F-test statistical value is 5.396. This is our value. Now, in order to be very sure that our decision is right, our sample are right, or in order to say our samples are saying right about the population, or in order to say what we are saying is right, or in order to say that our alternative hypothesis is right, we have to compare our test answer with our eighth step, that is, we have to find a critical value. In order to find out a critical value, we have to understand a table. The table in our case is known as F distribution table. In order to find out a critical value, we have to match two values. We know very well that we have selected in the beginning that how much fear we have, and our sample will not represent the population. So always pick a distribution chart of 5% fear, because our confidence is 5%. So we know that between the group is always on the numerator and within the group is always on the denominator. In our table, the column represents degree of freedom between the groups, and our rows represent the degree of freedom, that is 15 minus 3, 12. So we have to see in the table, we have to match V1 with V2. So we have to match V1, which is, in our example, it was 2. And we have to match it with our V2, that is, in our case, it's 12. So if you matched 12 and intersected with 2, you will see the value is 3.885. It means when we have 5% fear that our sample will not represent population, our critical value will be on this 2 degree of freedom is 3.885. Now once we understand the table, we can finally understand our last step, that we will compare the F-test statistical value to F-test critical value. Now we know the basic rule is that if F-test statistical value is greater than the F-test critical value, one situation will be like this. And one situation will be like this if F-test statistical value is lesser than the F-test critical value. What kind of decision we will take? If F-test critical value, statistical value is greater than the F-test critical value, you can say you are right and you can reject the null hypothesis. It means you can finally say that population mean of all the three groups are different. It means your sample are right representative of the population. If F-test statistical value is lesser than the F-test critical value, you can say I am wrong and I cannot reject the null hypothesis. I still have to take more samples to prove myself right. It means population mean of all three groups are same. You have to believe that. In our case, our F-test statistical value is 5.39. and it is greater than the critical value, which is 3.89 as per our F distribution table. It means we can finally say that I can reject the null hypothesis, and I can easily say that I am right. I can easily say that my population is the right, my samples are the right representative of the population. I can easily say my alternative hypothesis is more stronger. I can easily say that all fertilizers population means are not equal. So we have to conduct these 9 steps in order to know the value of F test statistical value, or in order to make a decision. You know, from the beginning of my lesson that I told you that in the end we can easily understand that what is a ANOVA statistical test. Remember, an ANOVA is a statistical test. It means we have to take samples in order to predict about the population. Second thing we have to keep in mind, it is a hypothesis test. It means we must have to do step 2. We have to make 2 hypotheses. We cannot do ANOVA without making a hypothesis. The fourth thing we have to remember that it is a hypothesis test, but it is a parametric type of hypothesis test. It means our distribution of population, as we remember in our assumption, it will always be a normally distributed data, because a parametric test can only be conducted on a normally distributed data. The data should be very much close to be on normality. The ANOVA test, now we can understand, is basically what we did in our exercise. We squared the differences, right? So it actually was a variance. And we know what is F test. F statistical test is equal to between the group variance upon within the group variance. So an ANOVA stands for analysis of the variances. Do you know that from a long time, many people are giving their own models of ANOVA? But ANOVA became very famous when it was given by British scientist Sir Ronald Elmer Fisher, who you also know that he is the father of the modern statistics. Remember, Ronald Elmer Fisher is the father of modern statistics. And in his famous book, he write down ANOVA test, and from that day it started becoming very famous. It started becoming very famous among researchers, and the book in which he wrote about it is Statistical Method for Research Workers. And it's not the only test that can be done on ANOVA. And ANOVA can be done one-way ANOVA, and one more famous version is two-way ANOVA. And there are many other models as well. But now today's class, what we did was a one-way ANOVA. And once you know about one-way ANOVA, it can have very good knowledge about two-way ANOVA as well, which we will do in our next class. So dear students, thank you so much for listening to this lecture. I will see you in my next class with one more lesson of ANOVA. Thank you.